Now in this problem we have a parabola that's on our base, and all our cross sections are semi-ellipses, so half an ellipse. So the parabola there is 16 is equal to y squared is equal to 16x, and we go a distance of h. So, and we're going to end up with our thickness in terms of h because we're going to let x be equal to h. So we want to show that the area of the semi-ellipse would be that. So remember that the area of an ellipse is pi AB. So what we need to do is get A and B, our minor and major axes, into that equation. So we've got to manipulate it. So what we're going to do, we're going to look at our diagram here, and we've got, if that's going across h, then that would be 4h there and minus 4h in this direction. So that means our semi-major axis there would be 8 root h. And then we can look at that and be able to get our semi-major axis, because we're told that our semi-major axis, the minor axis is 1/2 the major axis. So the minor axis would have been 4 root h, so the semi-minor axis is 2 root h. So A and B then, A gives us our length of our semi-major axis, and B our length of our semi-minor axis. So, and that's what A and B are, the semi-major and semi-minor axes. We sub those in, we get 4 pi h as our area, as our cross-sectional area. The volume then, between 0 and 6, 4 pi h dh, where we integrate and we get 72 pi. And the last part, we're told to rotate that volume, that area that's created by the parabola around the axis. So y squared gives us 16x, because, and that's gives, when we integrate that part, to give us 8 pi x squared, and between 0 and 6 gives us 488. And we're asked for the relationship between it, so it means that Q, that this is this volume Q, is 4 times the volume of P. There's our relationship. In question 4 here, we've got an area in the green here, which is shaded, and it's between 2 and 10 under this curve 2 of x minus x squared, and it's rotated about the y-axis to form a solid, and we want to use cylindrical shells to calculate the volume of that. So we take our typical shell, our typical thickness there, we have it rotate around, we get our rectangular prism. It's going to be delta x, and our radius 2 pi r, our delta, which is going to be x there, so the radius of x, height of y, so that's where we get our volume being there, our cross section. So we get 12x minus x squared times 2 pi x squared, so 2 pi x, so we expand that out. We're going to be going between 10 and 2 and 10 with the 2 pi up the front. We integrate, and the integration is not too bad. We able to integrate both those, sub in 10 and 2, and then we're able to get 2944. So that one's not too bad as harder questions go. So be careful with them. Make sure you're getting your correct limits of integration, your correct values for the height and your radius, so you can get your circumference along the base of the rectangular prism.